What's up, guys? Let's continue with the next part of thermodynamics. The good thing here is we finished all the difficult parts. What is remaining is all less important for physics exam. But today's class, I feel, is the today concepts I'm talking about. I think is my favorite. Okay. It took a long time for me to understand what are we trying to talk about because nobody came and actually spoke to me about all these concepts. I mean, because end of the day, when I'll tell you the same thing, not there in the syllabus. Okay. But if you see, uh, till today, if you can stick on to, if you can hold one concept in physics throughout your career, I think this would be the topic. Okay. We're going to talk about entropy. But before that, since we solved numericals in the previous class, we shall be talking about what and all laws helped us get those numericals right. Okay. So you'll come across something called as Hess law, that law, this law. So basically, I'll send you the PDF. Just go through it. The numericals is what I wanted to teach. So that has been done. Apart from that, all those entropy or formation, all those one markers, just by reading through it, you'll be able to understand. There's no concept. It's only a definition, which is not at all difficult. Okay. One marker definition. Is it important? Sometimes only they ask. Okay. Now, what is more important is something called a spontaneous process. Always understand one small thing. Spontaneous opposite is non-spontaneous. Everybody knows this. Both of them depend on one concept called as Gibbs energy. So to define spontaneous or non-spontaneous, if you're able to understand the meaning of Gibbs energy, more than enough. This also is not that interesting, but the most interesting part, in fact, I would encourage you guys to watch a number of YouTube videos based on this concept called as entropy. Now, obviously, don't watch YouTube videos on physics because that's what I'm trying to do here. I'm teaching the same concept, but the application wise, I'll give you a few applications. This is a superb concept. People feel enthalpy is the most important part. Yeah, in this chapter it is according to the syllabus, but entropy is superb. Fine. In fact, if I'm able to find on YouTube link, okay, I'll send you that link or based on entropy. Just watch it. Lovely video it is. And first of all, what is the meaning of it? Meaning is how random you are in life. How random you are in terms of life. Okay. Randomness is called as entropy. So in terms of defining it, it is called as degree of disorder or degree of randomness in a system or of a system is called as entropy. So this is what everybody mugs up. That is what writes. You guys will get marks. Fine. What is the actual meaning of entropy here is understand one thing. Disorder or randomness meaning there's always an old saying which tells if you wanna, I mean, the only way to destroy something is not by doing anything. Remember this. The only way to destroy something is just by not doing anything. You need not take a bloody hammer and hit something. Okay, it'll automatically fall if you don't even do anything. I'll give an example. In order to in order to not pass your exams, all you have to do is just don't study. Okay, just don't study. You need not harm yourself. You need not tell I hate. Don't do anything, and automatically you'll fail in your exams. So that is the meaning of entropy. The more lazy you are, the more lazy you are, the more random you tend to become. If the more random meaning what? You are disorder. Okay, you are not at all. I mean, you are disordered. You are not in order. Not following a proper order. Okay, which means you are following a disorder. Wherever there is disorder, all those concepts are called as entropy. Okay, all those concepts are called as entropy. Now, again, so if you wanna break a building, okay, it might take a long time, but just don't maintain the building. Let's say there's some kind of plumbing thing, don't do anything. Let's say there's a leakage in the wall, don't do anything. After some years, automatically you will see the building falling off. Okay, so that's the whole point. You not doing anything will lead to a lot of disorder. The disorder in a system is called as entropy. Super point this is. In other language also, I'll tell you. Let's say I'm pretty sure you guys take a you guys shower every day. Okay, let's say you don't shower and automatically everybody sitting here listening to the class have some kind of hair. Your hair tends to, I mean, your scalp tends to produce more amount of oil, which has to be removed from the body using either a soap or a shampoo. Okay. You tend to, let's say you do not wash your hair. It tends to become more rigid. Then you start off with all your dandruff and all those things. Eventually your hair starts falling. Okay. And because of this, a lot of diseases and all those, n number of infections will start off just because you did not take bath. You did not want to harm yourself. You did not take bath. And that kept on happening for a long time. So if you want to build something, you'll have to put in an effort. If you want to destroy something, just do anything, just don't do anything with respect to it. Ignore it completely, and automatically it will fall down. Automatically. This concept in life or this concept in physics is called as entropy. Simple. Okay. Now, Apart from this, each and everything else you'll be able to learn on your own based on the PDF. Okay. Now, what does spontaneous? Okay, this is the about randomness. My favorite concept is entropy. Unfortunately, I can't go any deep with respect to this because of the limitations we have based on your syllabus. Okay, but if I find the process, if I find the video, please I'll send it to you. Watch that video. It's superb. Okay, it is based on entropy itself. Now, talking about spontaneous process, as the name says, it is spontaneous in nature, which means, okay, the definition goes like this: the process that takes place on its own under certain conditions. So this is like a system which is built on automatically. Okay, so automatically, if you go and switch on, let's say, a rice mill, how does it work? At this point of time, there are a lot of mills where it does not require any laborers. You just go switch on the thing, the complete conveyor belt starts off the system, and this happens only under some condition. Now, what are those conditions? Example, for the in the rice mill case, electricity has to be there. Rice has to be there. There has to be one person to go and switch on the thing, and all the parts has to be working. All these things are the conditions. If all these conditions are kept up to date, okay, automatically the machine keeps on working, and that thing is called as spontaneous process. Now, automatically, the opposite will be called as non-spontaneous. All these things are important, but not in terms of definitions, but in terms of Gibbs free energy. I'll tell you what that means, anyways. So basically, let's say a non-spontaneous process is where it always requires a invigilator. Okay, always require an external person. So let's say you talk about construction. A machine can't go and build a house. So for that, there has to be a contractor. Under him, there'll be laborers. Under them, there'll be a number of whatever. There'll be teams which work, and eventually they will be able to pull off a mall or whatever, and a number of things. So this requires some kind of external agency or external factors. Wherever external agency is required, all those places will be called as non-spontaneous in nature. Okay, they don't react on their own. For example, let's say corporate. Let's say you want to take a holiday. You have processes. You have sector A, sector B, sector C. So let's say you first ask your A, then for leave, and that message passes on to B, and from then C approves, C tells B okay, B tells A okay, and the A is going to tell you okay. This is the meaning of thing. So basically, you are not able to take your own decision, which is that's the exact meaning of non-spontaneous in nature. Okay, that's how it is. Now, concept of entropy we finished. Gibbs free energy. Now, understand one small thing. Gibbs free energy. Okay, 1 second. Since we spoke about entropy, in spontaneous process, okay, in spontaneous process, entropy, which meaning disorder, or what else? Randomness is always increasing. Makes sense? No, because there is nobody to 100% makes sense. No. For example, if the college people of your if your college told you're supposed to attend college, but there is no minimum attendance, 100% you will not go to college. It is, will you bunk all the classes? No. Minimum you'll have around 10 to 20% of attendance. The remaining thing, it's on your own. The reason you're actually going to college is because 100% not to study. Second thing is attendance. You'll be like, bro, if I miss classes, I won't get attendance. And attendance is what is required for me to write an exam. End of the day, I want to write an exam. I don't want to skip exam. Okay. But for me to write an exam, the criteria is I'm supposed to have attendance. And that attendance depends on my teacher as well as me. So this is, if there is no external agency here, 100% you wouldn't have gone. So what you guys are doing in college is a non-spontaneous process. You do not have the decision in your hand. But just imagine you had the decision in your hand, your disorder or your randomness will keep on increasing. You might leave the house because of your parents. Okay, they might scold you. But once you leave the house, are you actually going to college? That might, the answer might not, the answer is actually a no. You might go near college and escape from there because randomness. Attendance is the only external agency which is holding you back, which means your case is a non-spontaneous process. Just imagine it's a spontaneous process. That in that case, randomness keeps on increasing, which means you might be like, okay, Monday, let's go to forum. Tuesday, let's go to some random mall. Wednesday, let's go to Garuda Mall. Friday, let's go to some movie. And Saturday, let's go to some kind of pub. All these things might happen, which means randomness keeps on increasing. Wherever it is a spontaneous process, all those places, entropy also keeps on increasing. Simple, straight to the point, nothing else apart from this. Okay. And what's the relation? This is the last concept. What's the relation between Gibbs free energy and spontaneous process? Very simple. If delta G, which means Gibbs free energy, if it is negative, okay, three things I'll tell you. It can be positive, it can be negative, it can be zero. Delta G means change in Gibbs free energy. Now, if it is negative in nature, then it is spontaneous. If it is positive, then it is non-spontaneous. If it is zero, then it is said to be at equilibrium. This is where we end the chapter, and this gives us the lead to the next chapter called as equilibrium. Okay. Now, what is Gibbs free energy? I can teach you right now, but I won't, because it makes more sense for me to teach in terms of equilibrium. But if you're trying to understand the meaning of Gibbs free energy, very simple. Guys, 1 second, I forgot to tell you something. Entropy is always represented by letter S. Remember this. Entropy is always represented by letter S. H means enthalpy. Okay. Now, how do you define Gibbs free energy in terms of this chapter? Okay, one line definition I'll give you, but in depth, we will be learning more about it in your equilibrium chapter. That's a superb chapter. Okay. So, Gibbs free energy, don't get confused. Delta G meaning change in Gibbs free. Here, I'm going to talk about Gibbs free energy is equal to H minus Ts, where H is nothing but enthalpy. We know this. Enthalpy we learnt. Okay. Uh, T always means absolute temperature in Kelvin, basically. Absolute temperature. S means entropy. So this is the meaning of formula of Gibbs free energy. But what they'll ask you is this only, these three. Okay. But this is very important point. In spontaneous process, the entropy keeps on increasing. But this chapter leads to the next chapter called as equilibrium. Very, very, very important it is, and it's easy. So what I would do is I'll send the PDF for you guys. Just go through everything. You will find few one marker which I haven't done, enthalpy of formation and all those things. That is not important. That was important only for numericals. Doesn't mean you guys will skip that. Please do it. It's just that don't pay too much attention to it. Maybe spend like 5 minutes to finish off all the one marker definitions. That's it. Okay. Limitations of one thing is there. Limitations of first law. This will come. Please mark it up. Okay. There's nothing explanation. There's no explanation here. They might ask you for 2 marker or 1 marker. Okay, please mark this up. I'll send the PDF to you. Apart from this, conceptually, everything is covered. Okay, definition wise, just go through it. There's nothing to explain in that. Okay. Next class, we'll do equilibrium. See you. Chapter's done. Practice those numericals again. That's the most important part in the chapter, and entropy part. I wanted to teach entropy in a different class. That's why I finished it off. But today's class, 100% 2 marks will be asked. 100%. Either here or the spontaneous or non-spontaneous, whatever. Okay, simple. Remember in terms of college definitions, it'll help you guys remember or retain in your memory for a longer time. Cool.